A simple random sample of size n equals 200 is obtained from a population whose size is big N equals 25,000 and whose population proportion with a specific characteristic is p equals 0.65. Describe the sampling distribution of p hat. So to describe the sampling distribution, we need an average, so we need mu p hat, which is easy because it's just p every single time. There's nothing to change. So that's 0.65. And then we need sigma p hat. Sigma p hat, we have to use that formula. Square root of p times 1 minus p over n. So then we get the square root of 0.65 times 1 minus 0.65 divided by n. So now remember, our formula calls for little n. They may throw a big N to confuse you. Don't worry about it. Always look for a little n, small n. So that's divided by 200. So then we go to our calculator. We type it all in exactly. Square root, open parenthesis, 0.65 times 1 minus 0.65, close the parenthesis, divided by 200, and enter. There's your standard deviation. So we get 0.033, what was the last one? 0.337. So there's our standard deviation. B. What is the probability of obtaining X equals 136 or more individuals with this characteristic? So in the book, they give you this portion of the problem. Right? They give you X equals more than 306. They don't give you this part. Right? They don't tell you that your p hat is equal to 0.68. So what we have to do is make X into a p hat. So for B, we need to change X into a p hat. So to change X into a p hat, we simply need to make a fraction out of that number. So our formula for p hat is equal to X divided by n. Our X here is 136. Our n is 200. So when we do that calculation, our p hat is 0.68. Okay, so that's where that 0.68 comes from, this little fraction. So now, we need more than 0.68. Right, we need more than 0.68. So if we think about that normal curve, 0.68, we need everything to the right of 0.68. If we need everything to the right of 0.68, we need to make sure we shift our upper bound and lower bound numbers. So I'm going to go to the calculator. We're going to do second vars. We're going to do normal CDF. We need to have the lower bound number, so that's where we're starting at, so 0.68. Our upper bound number is going to be the big positive one, so that's 1E99. Our average, which is our mu p hat, 0.65. And then our standard deviation, so 0.0337. We hit enter, and that's our probability. So our probability would be 1.87. So that equals 0.187. Next, we have to figure out what is the probability of obtaining X equals 118 or fewer individuals with this characteristic. Again, they give you an X, right? You need to change X into a proportion, right? You need to make it some sort of fraction. So we make X into a p hat. Let's backtrack a little bit. we're going to make x into a p hat. So here for C, we're going to turn x into p hat, and p hat is equal to x divided by n, which is equal to 118 divided by 200. So when we do that, we get some decimal. That decimal will be this number here, because I did it for you. I gave you the information to kind of help clear up what you have to do. So now we need everything less than. So now normal curve, 0.59, less than 0.59 is everything to the left. So then in our normal CDF, our lower bound number is going to be negative 1E99. Our upper bound number is going to be that 0.59. Second, vars, normal CDF, negative 1E99, 0.59. That's our upper bound number. Our average, 0.65. Our standard deviation, 0.0337. Hit enter. And there's our probability. So the probability for that, for the C, the answer for C, 0.0375. 0.0375. There's your probability of getting somebody this idea of x being 118 or fewer.